Okay, we have solving radical equations. This is lesson 11.3, which is on 629. We're going to do two types here, the types with radicals on one side and radicals on both. Okay, I'm just going to start doing some sample equations. On page 629, you have example 1 that you can look at, and you have the square root of x minus 3 equals 4. Now we're just going to treat these like regular two-step equations, okay? We're going to treat the radical just as if it's the variable. And we're going to add 3 to both sides. And then so that will cancel, and we're left with the square root of x equals 7. Well, then we're going to do the inverse of square rooting, which is squaring, and we need to do that to both sides. I like to put the entire equation in parentheses. That way I know I'm going to get x equals 49. So then we can put it in. Is the square root of 49 minus 3 going to give me 4? Well, the square root of 49 is 7. 7 minus 3 is, in fact, 4. Now, sometimes we might have the entire expression under the radical. And if that is the case, then we need to first begin by squaring the equation. So then we result with what was under the radical. So x minus 3 equals 16, because 4 times 4 is 16. Then I add 3 to both sides. So x, in fact, equals 19. And so then we can substitute that in and say, is 19 minus 3, which is 16, so is the square root of 16 4? And in fact, it is. We'll do a couple of additional examples here for you. Let's do quick check 1b and 1c. So the square root of a minus 4 equals 5. And then our other one will be the square root of c minus 2 equals 6. Okay? So let's take this one first. Square root of a minus 4 equals 5. So let's add 4 to both sides. So the square root of a equals 9. Then we'll square both sides. So a, in fact, equals 81. So the square root of 81, which is 9 minus 4, 5. Yes. Okay? Over on this side, we need to square first. So we have c minus 2 equals 36. We will add 2 to both sides. So c, in fact, equals 38. Is 38 minus 2, which is 36. And the square root of 36 is, in fact, 6. Additionally, we will have problems like example 3, where we will have radicals on both sides of the equation. So we have the square root of 3n minus 2 equals the square root of n plus 6. So what do you think we want to do here? Well, we're going to want to square the entire thing, right? So we can get rid of the radicals, and then we end up with 3n minus 2 equals n plus 6. Okay? And then we continue to work through. Okay, so I'm going to add 2 to both sides, and I'm going to subtract an n. I like to do those sometimes in both steps. Those are what's going to cancel, so I have 2n equals 8, so n equals 4. Then I can go back in and substitute it, okay? So 3 times 4 minus 2 equals 4 plus 6. Square roots of all of that. 12 minus 2 is 10, so the square root of 10 equals the square root of 10. And that, in fact, is true. Okay? That's just another type of example of solving radical equations. We will do one more, and it is quick check number 3. The square root of 3t minus 4. plus 4, not doing very good this afternoon, equals the square root of 5t minus 6. Okay? And we would, in fact, square both of those first. So we end up with 3t plus 4 equals 5t minus 6. Okay? Two-step equation. Let's add 6 plus 6 minus 3t minus 3t. Bada bang, boom, 10 equals 2t, t equals 5. 3 times 5 is 15. 15 plus 4 is 19. So the square root of 19 equals 5 times 5 is 25. 25 minus 6 is 19. So the square root of 19 equals the square root of 19.